binding energy curve. So there we had like this, no? Two lighter nuclei. So let me take two lighter nuclei in this one. When they combine, what happens? They'll form another lighter nuclei. So these are the X, Y, this Z. So if I reaction, you check it. When I go and check it, the binding energy of this, these are the parents, they're the daughter. The binding energy of the daughter form will be greater than that of parent. So when two lighter nuclei fuse, again we'll get lighter. Don't say heavier nuclei. Suppose say two hydrogen deuterium combines, we don't get copper or aluminum, no? So again lighter nuclei, helium or tritium like that. So when two lighter nuclei fuse, again we'll get a lighter nuclei, but the binding energy of the daughter will be more than that of parent. So energy will be released here. But what is the major problem? They have to fuse. See, fission is very easy, but fusion, what happens? We have to bring the lighter nuclei towards each other. So here what we are taking is the deuterium and the tritium. We can take any example. So there's a basic equation. So energy will be released when you go like this or when you come like this. There's a fusion. There's a fission. So when two lighter nuclei combine, so what happens? The energy will be released here. So what is the advantage with this is like the fuel is very cheap, abundant. As long as Earth is there, this hydrogen, tritium, deuterium will be available. So if we get success here, I think the problem of energy will be solved forever. Not only that one, we can better say that forever it will be solved, and we don't have to bother anything with the fuel. So how that reactions occur? So let me just write some basic reactions. Just wait, I'll get into the topic. I think this is, I'll come to later on, you'll get confused this. So what are the energy, how they'll be released? So let's start with two deuterions. If they combine and they'll form a helium nucleus. What is a deuterion? It contains one proton, neutron. And finally what happens? We'll get like this, no? So when they have to fuse, they should come. So when they come nearer, what is the problem? The proton, what happens, will exert a force, no? So we should overcome that electrostatic force. So what is the basic requirement? This particular thing, they should be, when that electrostatic repulsive force can be overcome when they are in plasma state. So what is the biggest problem? The parents which are there in the fusion, so they should be made available in the plasma state. What is the next problem? Plasma state. Okay, fine. What is the plasma state when it will come? At a temperature of 600 Kelvin. Then what is the biggest problem is way to hold this particular fuel. There should be a container, no? So is there any metal which can exist at 6000 Kelvin? I don't think so, no? We don't have any metal which can exist. So how to hold this particular fuel? Say uranium, okay, uranium ball. But here, what is the biggest problem with the fusion? That particular fuel, what happened, should be made available at 6000 Kelvin. As fuel is available. Sir, hydrogen, what is there in hydrogen or deuterium? At 6000 Kelvin available. But how you contain it? Because the fuel is at temperature of what? 6000 Kelvin. So for that, what happened? We don't have any particular bowl, or better say, like I say, you want to drink milk. You need bowl, no? Liquid gases, they don't have shape of their own. So we need container. So to place this particular deuterium in this bowl, we do have any metals which can exist at this temperature? The answer is no. So therefore what happened? We have to generate a magnetic field. The magnetic field should be of this shape. And here is what the deuterium in the plasma state will be available. And what is this blue color? This blue color, everything is magnetic field. I'm just showing the rough idea. This is the magnetic field. And this is what plasma state. Deuterium. So what is the biggest problem? We have deuterium, and I can bring a temperatures of 6000 Kelvin. I can make the fuel or the deuterium to attain that plasma state. But the bowl is a problem. So we need a great devices. Generating this bowl is the biggest problem. Till date, we are unable to get uncontrolled hydrogen bomb. Yes, we have, but controlled hydrogen bomb weapon, we need this particular bowl. And there's a magnetic field. So generating a magnetic field which can hold that plasma state is what the technology, which we are unable to get properly. And by 2025, they're planning to have the almost they're going to get success is what they're telling that one. India, 7 nations are there where India is one of the major contributors because the nuclear technology, India stands among top 10 or almost you can put along top 5 that one, especially in the fusion reactors. No, India is having well advanced scientists out there. So by 2025, they're planning to have a breakthrough, an experimental thing they're going to do. And it's being constructed. The fusion reactor is being constructed in the European country, and India, 7 countries have come together where the 30% of technology is flowing out from India. This one, the construction of bowl is what the skill. Therefore, the engineers are trying a lot to construct this bowl. Do you think what is the size of this reactor? Almost like a 4 stadiums. LB Stadium is there, no? The size of 4 stadiums. That much of big reactor will be there. Once we get a success controlled hydrogen, like a controlled fusion reactor, slowly with after some 100 or 200 years, maybe will technology will improve. We may go further improve that one. So this is what I actually think. So now what all we discuss is a theoretical, nothing to do with practical. So just only proposed nuclear fusion reactor, we say like that. So this bowl is a problem, magnetic field. So any one of you who are very much interested in particle physics, do learn how to generate such a magnetic field which can hold plasma state. If you can break through, first you'll get Nobel Prize. Then the whole humanity will be indebted for you. Because what is the reason? Deuterium. From where do we get? You go to ocean, lake, ponds, anywhere, no, you'll get water. And in that water pen, around 2% is what deuterium. For every 1 liter in a water pen, 2% will be there. And to extract the deuterium, we need around say like a 1.6 rupees to extract deuterium from 1 liter water. And this will become so cheap that you can have your own like a deuterium extractor. That one, it's very cheap deuterium because water is available abundant, no, on the earth. You go to ocean, you take any amount of water, anybody will object, nothing, no, and you extract deuterium from it. To extract in 1 liter 2% of it, it will just cost you 1.6 rupees. I think the fuel is abundant, no, forever the fuel is available. If you get success, problem will be solved. So we do have all these particular equipments which will extract deuterium from the water processing. So there's no problem with the fuel now. The only problem is the bowl, which will contain that fuel, which will be at a higher temperature, 600 Kelvin. Okay, this is about the thing. So not only this deuterium, we do have many other reactions are there. Okay, let's work out some numericals on this. I'll write few more reactions. Let's go for a few more reactions. I think if you see the different reactions, where we are, yeah. What are the different types of fusion reactors? So if you look at the sun, we have proton-proton cycle. What are other fusion reactors? So their hydrogen will combine. So we'll get deuterium, beta, then neutrino. Then how much of energy? 0.42 megaelectron. Just do remember any possibility of asking them in exam. Now if they deuterium and hydrogen, if they combine, will get helium, gamma photon. Sorry, this will be gamma photon. This will be neutrino. Then energy of, if you see this, this what proton cycle. What happens in sun? This one. So there hydrogen will combine, will form deuterium, then electron, and the neutron will be this much of energy will be available. Next, again, the two deuterions will combine to form helium and gamma photon, this much of energy. Then again, the heliums will combine, will get the helium. I think this helium isotope, this helium nucleus, alpha particle, then we'll get hydrogen. Then this energy. This energy is what we're getting sun's radiation. We have another carbon nitrogen cycle. Please do refer NCERT book. Just only I have to write equation. Just I picked up few. So like that, we'll get a different types of the fusion reactors. So here, from where that ball is available, see the sun itself is made up of hydrogen. There's no problem with the container. And the gravitational power of the sun, the gravity of the sun is holding that particular total hydrogen. Like this. And then what will happen? That because of high temperature, 6,000 Kelvin of that order, 4,000 Kelvin, the hydrogen will fuse, and these particular reactions are taking place continuously. Means, sir, one day the hydrogen fuel will get over. It will get over. So if you look at the lifespan of the sun, half of the lifespan got over. Because one fine day there won't be sunrise as it is. Mass is not conserved. Okay, that one. I think one neutron should come here. One neutron will come here. Fine. We have